All right, today we're talking about theoretical probability. Starting with number 1, you roll a standard number cube. That's a die. Looks like this. It has sides 1, 2, 3, 4, 5, and 6. That means they want me to find the probability of each event below. Write your answer as a fraction in simplest form. So since this die has 6 sides, my possible outcomes, all the possibilities are 1, 2, 3, 4, 5, and 6. Because I could roll a 1 or a 2 or a 3 or a 4 or a 5 or a 6. These are all this is my total outcomes. How many are there? Well, there's 6. So that means the bottom number in my fraction is going to be a 6 because there's 6 possible outcomes. Well, how many of them do I want? I want to roll a 5. That's just one of my outcomes. So my numerator is going to be a 1. If I want to roll a 5, what's the probability that I roll a 5? It's one option out of the 6 options. So 1/6. Is that in simplest form? Yes. Number 2, I want to roll a 1 or a 6. This time, instead of rolling a 5, I want to roll a 1 or a 6. How many options is that? 1, 2. 2 options out of how many? Well, there's still 6 total options, so 2 out of 6. And I could simplify that to, if I divided this by 2 and I divided this by 2, I could get 1/3. And that would be my fraction in simplest form, 1/3. So the probability that I roll a 1 or a 6 is 1/3. What about the probability that I roll an even number? What are the even numbers in my total outcomes? Well, 2 is an even number, 4 is an even number, and 6 is an even number. So I have 2, 4, and 6. I have 1, 2, 3 possibilities out of 6 total. 3 out of 6 could be simplified to 1/2. So that would be my probability for rolling an even number would be 1/2. Now let's try number 2, where we're spinning a spinner this time. So I have 8 outcomes. I could get a 1, a 2, a 3, 4, 5, 6, or a 7, or an 8. They want me to find the probability of each of these and write my answer again as a fraction in simplest form. Okay? What is the probability that I spin a 7? Well, how many total outcomes are there? What are my total outcomes? This is going to be my denominator of my fraction. There's 8. And how many do I want to choose? In this case, I want the 7. So that's one possibility out of 8. 1 out of 8. And it's already in simplest form. So let's look at B. What's the probability that I get an odd number? Okay. The odd numbers are 1, 3, 5, and 7. That's 1, 2, 3, 4 options out of my 8 total. And I could simplify that. If I divide this by 4 and divide this by 4, I could get 1 out of 2, or 1/2. And that probability of getting an odd number is 1/2. Last one, number C, probability of getting a 1, a 2, or a 3. Well, that's 1, 2, 3 options out of 8 total. Can I simplify this at all? 3 over 8? No, because they don't share any common factors. So this is my simplest form. So the probability that I roll a 1, that I spin a 1, 2, or 3 is 3 out of 8, or 3/8. Let's go down to number 3. A bag contains 3 blue, 4 red, and 5 yellow marbles. Find the probability of each of these events. Write your answer again as a fraction in simplest form. First, we need to find how many total outcomes do we have. Just like we did here and here, what is our total outcomes? How many things could I choose? Well, if there's 3 blue, 4 red, and 5 yellow marbles, how many marbles are in the bag in total? 3 plus 4 is 7. 7 plus 5 is 12. That means there's 12 total outcomes. So what's the probability that I choose a red? Well, how many reds are there? There's 4. Out of how many total? 12. How could I simplify 4 out of 12? I could divide those both by 4, and I would get 1/3. So the probability that I pick a red marble is 1 out of 3. What's the probability that I choose a yellow marble? Well, how many yellow marbles are there? There's 5 out of how many total? 12. So 5 out of 12 is my probability, and I cannot simplify that. What about the probability of getting a blue or a yellow? Well, there's 3 blue and 5 yellow, and 3 plus 5 is 8. That means I have 8 possible outcomes that I could choose. If I choose a blue or a yellow, I win. So that's 8 possibilities out of my total 12. And I could simplify that to be, if I divide this by 4 and I divide this by 4, I would get 2/3, 2 out of 3. That's my probability for choosing a blue or a yellow marble. Now we've done 3 things on theoretical probability where we're doing these different outcomes. We did rolling a cube, spinning a spinner, choosing a marble out of a bag. Now let's look at one example of a problem that's a little bit different, but we're still using the idea of theoretical probability. On average, 35% of Adams students like the White Sox. Out of 723 students, about how many like the White Sox? In this case, we're going to be setting up a proportion. Okay, so the proportion is like going back to mod 8 where we had scale factor. Or was it mod 9? Anyways, when we talked about scale factor, I could set up 35% is the same as 35 out of 100, right? Because we know that percents are always, it's like out of 100%. So 35 out of 100 equals, we want to find out of 723 students, how many like the White Sox? Well, the how many is our variable. That's our x. So our unknown out of 723 students is going to be the same proportion as 35 out of 100 students. Okay, so we're going to do what we did back in mod 8. We're going to cross multiply. So I need to figure out what's 100 times x? 100x. And what's 35 times 723? It is 25,305. So now I have to divide. This is like a one-step equation now. I divide by 100 to get rid of that 100 and get my x by itself. And if I divide that 25,305 by 100, I get 253.05. That means that about 253 students like the White Sox. Because I'm not going to say that 253.05 students like the White Sox. I'm not going to say I have 0.05 of a student. I'm going to round it down to the closest whole number, 235. And that would be my answer.